her, Sean. I'm Dr. Wallace.
Hi.
And I'm her assistant, Miss Devine. What brings you in here today?
My teeth have been bothering me lately. I think I have some cavities.
Okay, let's take a look at your x-ray.
Yes, it does appear here that you do have some cavities.
I have really bad tolerance to pain. Is there anything else we can do?
Well, we can try this new treatment involving peptide bonds and matrix degrading enzymes.
So what is a peptide bond?
A peptide bond is a chemical bond formed between two molecules when the carboxyl group of one molecule reacts with the amino group of the other molecule. This is a dehydration synthesis reaction, so a water molecule will be released as well.
Oh, cool. So how did you discover this treatment?
Found in the journal Biomaterials, published in August of 2016, it discussed research where Michael Koo, Henry Daniel, and other colleagues at the University of Pennsylvania performed a study to further enhance dental health. In this study, the researchers performed a single topical treatment on a tooth-like surface covered in saliva. The control group was treated with a buffer, while one experimental group was treated with the protein and enzyme treatment, and the other group was treated with chlorhexidine, an ingredient used in dental products such as mouthwash to kill bacteria. The bacteria were exposed to the treatments for 30 minutes. All three cultures were incubated for 19 hours and the results were analyzed afterwards. It was evident that both treatments helped kill bacteria. However, the peptide plus enzyme treatment was more effective than the chlorhexidine.
So how will this treat my cavities?
Well, the peptide protein treatment kills tooth decay-causing bacteria. However, when it is combined with the enzyme, it becomes a lot more effective. Together, the protein and the enzyme are able to degrade 60% of the biofilm matrix.
So how is this created?
Researchers were able to make the reprogrammed plants produce retrocyclin and petrogrin, two antimicrobial peptides with complex secondary structures. Retrocyclins belong to a group of proteins called defenses that defend the body against viruses, fungus, and other foreign invaders. Protecrins are proteins similar to certain defenses.
So is the treatment new or old?
It's been tried by multiple researchers, but it was not cost effective because it was too expensive to produce in a lab.
I'm a broke college kid. I don't have a lot of money. Is there any other ways?
Actually, it was found that by growing these plants with the peptides in them in Daniel's greenhouse, he was able to replicate the same proteins, ultimately making the treatment at a lower cost than in the past. Being that more than $40 billion is spent on healthcare annually, this treatment is great for people of a lower socioeconomic status.
So by it being so cheap, is it harmful?
No, it would not cause any damage to the cells in your gum tissue. But it is effective in preventing a biofilm from occurring as well as breaking down the biofilm matrix after it is already developed. Biofilm is the buildup of plaque that develops when you do not brush your teeth properly.
So is there any way I can prevent cavities in the future?
Well, for one, you can floss more. And second, Koo and Daniel also have the idea to create gum laced with these peptides. These proteins will be released when you chew and will help to prevent cavities and gingivitis. So you can try that in the future as well.
Another new idea is for people in other countries where items like gum are not accessible, people can chew betel leaves with the peptide bonds grown into them to prevent oral health. Poor access to healthcare is greatly increased because many developing countries are unable to afford the proper treatment they need. In areas such as the sub-Saharan Africa, South Africa, and Asia, many children have neglected dental needs. Due to the high risk of oral diseases and the inability to receive health care, patients are getting sick, and this results in an increased mortality rate.
Sounds great. We'd love to try it sometime.
Cool, we'll go grab it for you.
Yeah, so